So at the beginning, I have to apologize that I am an exchange student, so I do find some difficulty in reading out mathematical terms or equations, but I will try my best to make myself understood. In this solution presentation, I'd like to talk about a trigonometric rational function. By saying trigonometric rational function, I mean that a rational function we get by the limited times of addition, subtraction, multiplication, and division of the sine x and cosine x. And I'd like to use r sine x cosine x equals to r u v to demonstrate this r function, to demonstrate this t r function, So next, I'm going to talk about if this trigonometric R function has some special symmetrical factors. We can always get its integral by doing some specific substitution. There are mainly two cases here I'd like to talk about. The first case is like R negative uv equals to r uv. So if we can see that r function is actually an odd function of sine x. So because r function is a rational function, we can always get the u factor out of the r function. So we can get an RE function, which is an even function of sine x. So when we are doing the integral calculation, we can write like this. Get sine x out of R function and get RE function. Now we can make a substitution. Let t equals to cosine x, so we get negative r1 like this. So now by doing so, we can transfer the integral of a trigonometric function to a rational function about t. And so the second case is very like the first one. We have so now our function is actually an odd function of the cosine x. So by the same token, when we doing the integral calculation, we can have our cosine x out of the r function, so we get like this. And also let t equals to sine x, so we get an RE function. It is a rational function about t again. So now let's make an example. Suppose we have an integral calculation like this. Now you can see that this is actually an odd function about cosine x. So this is the cases we talked about in the second one. Now we can take cosine x out of our odd function, so we get this. And further, we could have this. And now it's obviously that we can make a substitution. t equals to sine x. So we get integral of 1 minus t squared 1 plus t squared dt. Now we get an RE function, RE rational function about the t. So the following is much more simple. We have so now we have dt. I'd like to separate the upper part. Okay, like this. And then we can have negative t, that's 2 arctangent t plus a constant c. And so we put our x back to our equation. So we have negative sine x plus 2 arctangent sine x plus constant. Okay, that's all. Thank you.